Use netconf to access an iOS XE router. This is the topology. I will use the router on the cloud from Sandbox. The interface and IP address on the router, a PC, use the CCNP virtual machine. The network configuration protocol netconf, defined in RFCs 4741 and 6241, uses Yang data models to communicate with various devices on the network. Yang, yet another next generation, is a data modeling language. This language defines the data is sent over the network management protocols, like netconf. When using netconf to access an iOS XE device, the data is returned in XML format. You will use netconf-client and ncclient, which is a Python module for client-side scripting. You will use ncclient to verify netconf is configured, retrieve a device configuration, and modify a device configuration. Required resources: a router. Okay, in my case, I will use a sandbox router on the cloud. Switch is optional, but use PC with CCNP virtual machine. Build the network and verify connectivity. You will cable devices, start the CCNP virtual machine, configure R1 for netconf and restconf access over an SSH connection. You will then verify connectivity between the CCNP virtual machine and the router, as well as test an SSH connection to R1. Connect the devices, start the CCNP virtual machine. If you have not completed lab, install the CCNP virtual machine. Do so now before continuing with this lab. Open VirtualBox, start the CCNP virtual machine. VirtualBox. This is my CCNP virtual machine. From settings, and not working, verify. You are using bridged adapter or use NAT. Use any. Okay, in this case I will use bridged adapter to connect my real network. Select your real adapter, is a gigabit interface in my case, and be sure this cable is connected. Is checked. Okay. Otherwise, use NAT, is a virtual network, but will work very good. Okay. In my case, bridged adapter. Okay. Start the virtual machine. Okay, ready. Enter the password. A student pass, case sensitive to log into the virtual machine is necessary. Configure R1. Console into R1 and paste the following configuration into the command line interface to configure basic settings and enable netconf, restconf, and SSH. Okay, I will use the sandbox router on the cloud, so this is not necessary. Go to developer.cisco.com. Okay, and login. You can use Google for login. Okay, ready, and go to DevNet resources. DevNet resources. Click on Sandbox. Get started with Sandbox. Okay, you can use regular devices and for example, iOS XE on CSR version 17.3.1 to reserve, or go to always on devices. You can choose iOS XE on CSR version 17.3.1, the latest codes, or iOS XE on CSR recommended codes version 16.9.3. If first, I will use version 17.3.1, iOS XE on CSR latest codes. Okay. You can choose any of these two, but I will use 17.3.1, or if you want 16.9.3. Okay, but I will use now 17.3.1. Click here. Okay, iOS XE or CSR latest code always on version 17.3.1. This is the name. Okay, the domain sandbox-iosxe-latest-1.cisco.com, SSH port 22, netconf port 830, resconf port 443, HTTPS, username, developer, and password C1SEO12345, C uppercase. Okay, so this is the device. Verify that CCNP virtual machine can ping the default gateway. In the CCNP virtual machine, open a terminal window. This is the terminal. Click here. Okay, first verify the IP address on the virtual machine. IP address. Okay, I got an IP address. It may vary in your case, but this is my current IP address. And ping to the router. The destination is 192.168.1.1 because the IP address on the router is 192.168.1.1. But in my case, I will not use an IP address. I will use this name. Sandbox iOS XE latest 1cisco.com. Being sandbox iOS XE dash sandbox iOS XE dash latest dash 1.cisco.com. Okay, enter. You can see the IP address of the device, but ping is not working. Okay, Control C to stop this process. Control C. Okay, 13 packets transmitted, 0 received, 100% packet loss. Don't worry about this because ping is not permitted on the device for security and for availability. Don't worry about this. If CCNP virtual machine has not received IPv4 addressing, check your physical connections between the host PC and the router. Establish an SSH connection to R1. Open PuTTY SSH client. Okay, open PuTTY. This is PuTTY. Okay, and enter the address for the router and open. Okay, in my case, it's not an IP address, it's a name. Remember this name: sandbox ISXC latest 1 Cisco.com. Port 22 SSH open. Okay, login is you should be able to log in the router with username and password. Okay, for the lab, the username is Cisco and password Cisco123 exclamation mark. But in my case, the username is developer and password C1SCO12345, C uppercase. Okay, is developer, enter, password C uppercase 1SCO12345, enter. Very nice. Okay, but this is very small. And close PuTTY. Are you sure? Yes. Open a new terminal. Right click here in new terminal. And you can use the following command for SSH access. SSH, the username developer, and the name sandbox ISXC latest 1 Cisco.com. Okay, enter, and the password is the username is developer, the password C1SCO12345. User is developer, password C1SCO12345. Enter. Very nice. Okay, keep your SSH session open. Use a netconf session to gather information. You will check to see if netconf is already running. Enable netconf if it is not, and verify that netconf is ready for an SSH connection. Then you will connect the netconf process, start a netconf session, gather interface information, and close the session. Check if netconf is running on R1. Netconf may already be running if another student enabled it, or if a later iOS version enables it by default. From the SSH terminal, use the show platform software yang management process command to see if the netconf SSH daemon ncclient is running. Okay, use this command. Okay, here, okay, enter on the router. Okay, CSR 1000B IOSXE. Okay, just show platform software yang management process. Enter. And ncclient is running. Okay, netconf client SSH daemon. is running. Very good. If netconf is not running, enter the global configuration command netconf-yang. Okay, configure terminal and netconf-yang. Then verify again, and SSHD should be running. Access the netconf process through an SSH terminal. You can establish an SSH session with R1 using PuTTY. However, the copying and pasting functionality in the SSH terminal window inside the CCNP virtual machine can be problematic. Therefore, use a command line window to start the SSH session with R1. Okay, try to not use PuTTY, try to use the terminal. Okay, just like this. And enter the following command in a terminal window. Enter the password. If you type the command incorrectly, use the up arrow key to recall the command that you enter. Define and edit your mistake. Okay, use this command and SSH access the algorithm. Okay, the host key algorithm, the username, the IP address or name of the device, port 830 for netconf. Okay, and the subsystem is netconf. Then enter the password. Okay. Okay, on the virtual machine, go to the another terminal. The terminal used for to verify the IP address ping. And enter SSH the host key algorithm equal plus SSH dash DSS. The username in my case is developer, and the name is this sandbox ISXE latest 1 Cisco.com. The port is 830 and the subsystem is netconf. Enter. Up arrow to repeat the command, and this is my error, is host key host key algorithm A uppercase. Okay, very nice. Enter. Yes. And the password, remember the password. Username developer, password C1 SEO12345 C uppercase. Okay, this was the user developer, the host name, but now the password C1 SEO12345. Enter. Okay, very nice. The router will respond with a hello message that includes all its capabilities. The end of the message identified with these characters. Okay, the end of the message identified with these characters. And the hello message shows all the capabilities. Okay, the capabilities. Okay, your session number is 129. And it's a hello message. Start a netconf session by sending a hello message from the client. To start a netconf session, the client needs to send its own hello message. The hello message should include the netconf-based capabilities version the client wants to use. Copy and paste the following XML code into the SSH session. Notice that the end of the client hello message is identified with these characters. Okay, and copy this. But I will copy all this to a notepad. Okay, all this. Copy this. Copy. Okay, all this to a notepad. Okay, all on the notepad and save the file. Choose a name. Save. Okay, and okay, and I will use Google Drive to transfer this to the virtual machine. Okay, this is the file. Very nice. Go to virtual machine and open Firefox. Uh, drive.google.com. Google.com. Enter. Access. Okay, this is the file and download. Save the file. Okay, and verify. Here, go to files, go to downloads. This is the file and open this file. Okay, and copy and paste the following XML code into the SSH session. Okay, copy this. Okay, but copy this, including these characters. Copy. Here and paste. Okay, now you can see session ID 129, capabilities, hello, and these characters. If not is working, try again, because the SSH session has a timeout that will disconnect you if you take more time to do this. On R1, use the show netconf-yang sessions command to verify that a netconf session has been started. Okay, use show netconf-yang sessions on the router. Okay, another terminal is this. Enter is okay, is disconnected by the SSH timeout. Enter. Control C. not responding. Okay, close this terminal, close, right click, open another new terminal. Okay, establish an SSH session, SSH, username developer, the name, sandbox iOSXE dash, sandbox dash iOSXE dash latest dash one dot cisco.com. Enter. Password C1SCO12345. Enter. Okay, very nice. And verify the session. Show netconf dash yang sessions. Enter. Okay, it's netconf. Be careful. Okay, now you can see the session 129. 129. Okay, is this session 129 session ID. Okay, if it's not working, try again, because if you will take more time to do this, the SSH timeout will disconnect you. Okay, send RPC messages to an iOSXE device. During an SSH session, a netconf client can use a remote procedure called RPC messages to send netconf operations to the iOSXE device. The table lists some of the more common netconf operations. Okay, get, retrieve running configuration and device state information, get config, retrieve all of part of a specified configuration data store, edit config, loads all or part of a configuration to the specified configuration data store, copy config, replace an entire configuration data store with another, delete config, delete a configuration data store, commit, copy candidate data store to running data store, log, unlock, log or unlock the entire configuration data store system, close session, graceful termination of the netconf session, kill session, force termination of netconf session. Copy and paste the following RPC get message XML code into the terminal SSH session to retrieve information about the interfaces on R1. Okay, copy this from RPC to these characters. Okay, and here on the text editor, from RPC to these characters, copy and paste here on this terminal window, paste. Recall that XML does not require indentation or white space. Therefore, R1 will return a long string of XML data. Okay, you should get this output. But in my case, it's not working. This is for the SSH timeout. Enter, enter. Control C. Okay, Control C and up arrow to start the session again. SSH, the algorithm, username, the name, port, and subsystem. Enter. Password C1SCO12345. Enter. My session ID is another session 133. go to the text editor up here and first start the session with a hello message from hello XML and S to these characters. Copy, then paste. Okay, very nice. Session ID 133. And then copy the RPC message, including these characters. Paste. Okay, and you should get this. The gigabit Ethernet 1, description, the IP address, subnet mask, gigabit 2, and gigabit number 3, all the information of interfaces. Copy the XML that was returned, but do not include the final characters. These characters are not part of the XML that is returned by the router. Search the internet to predefine XML. Find a suitable site and use its tool to transform your XML into a more readable format. Okay, on virtual machine, copy this answer for the from the router. Do not include these characters. Do not include these characters. Copy. Go to Firefox. Predefine XML. Okay, I will use the first result. Okay, copy this, paste, turn pretty, and now you can see this is more readable. Gigabit 1, gigabit 2, gigabit 3. Loopback 100. Close the netconf session. To close the netconf session, the client needs to send the following RPC message. Okay, copy and paste this in the virtual machine, the text editor. Okay, to close the netconf session, RPC message. Okay, this. Copy. Okay, 3 lines here and paste. Okay, close session. Enter. Not. Another enter, and okay, this is the Linux prompt. You will be returned to the terminal prompt, return to the router prompt and show the open netconf sessions. You will see that the session has been closed. Okay, another terminal, this, enter. Okay, Control C is not responding. Okay, because the SSH timeout. Close this, close terminal, right click here and open another new terminal. and up arrow and repeat SSH developer, the name, enter, password C1SCO1234, enter, and show netconf sessions, show netconf -yang sessions. Okay, there are no active sessions, okay, because you closed your session, okay, with very nice. And use ncclient to connect to netconf. Working with netconf does not require working with raw netconf RPC messages and XML. You will learn how to use ncclient Python module to easily interact with network devices using netconf. In addition, you will learn how to identify which Yang models are supported by the device. This information is helpful when building a production network automation system that requires specific Yang models to be supported by the given network device. Verify that ncclient is installed and ready for use. Enter the command pip3 list format columns to see all Python modules currently installed in the CCNP virtual machine. Your output may differ from the following, but you should see ncclient list as shown. If not, use the sudo pip3 install ncclient command to install. Okay, on virtual machine, this another window. Here, the Linux prompt pip3 list -- format equal columns, enter. And up here you should see ncclient version 067. Okay, and if it's not installed, use sudo pip3 install ncclient. Password for a student is this. A student pass as uppercase P uppercase, as student pass. Okay, already satisfied, already installed. Okay, create a script to use ncclient to connect the netconf service. The ncclient module provides a manager class with connect method to set up the remote netconf connections. After a successful connection, the return object represents the netconf connection to the remote device. In Python IDLE, create a new Python script that I called ncclient-netconf.py. Okay, on virtual machine, IDLE, okay, file, new file, and save this file. Save as on home student directory ncclient.netconf. Be careful with the name .py. ncclient-netconf.py. Okay, save. Okay, very good. And in the new Python script file editor, import the manager class from the ncclient module. Okay, this is the module. Okay, the module ncclient, the class manager. Then create a variable m to represent the connection method. Variable m represent the connection. The connection method includes all the information that is required to connect the netconf service running on the router. Okay. Note that the port is 830 for netconf. Okay, the host, you will connect the port, username, password, and host key verify false. If the host key verify is set to true, R1 will ask you to verify the SSH fingerprint. In a lab environment, it is safe to set this value to false, as we have done here. Okay, and copy this. I have this text file here from the module to this character. Copy this. And the editor paste. Okay, the module ncclient import manager, variable m, manager connect, the host, port, username, password. But remember, this is the host, this is my username and password. They are different, so here use sandbox dash iosxe dash latest dash one dot cisco.com. Port 830, username developer password C1 CO12345 KC uppercase. Save and run the program to verify that there are no errors. You will not see any output yet, but you can verify that the netconf session is active on R1 by entering the show netconf-yang sessions command. Okay, save and run module F5, run module. And look at here. Okay, no output, no errors, all is very good. Go to this prompt for the router, enter, Control C, Control C. It's not responding by the SSH timeout. Close this, close terminal, open and another new terminal. Click here, new terminal. Okay, up arrow, SSH, username, hostname, enter. Password C1SCO12345, enter. Very nice. And show netconf-yang sessions. Session 135. Very good. Add a print function to the script so that the netconf capabilities for R1 are listed. The M object returned by the manager connect function represents the netconf remote session. As you saw in part 2, in every netconf session, the server first sends its list of capabilities, which is a list in XML format of supported Yang models. With ncclient module, the received list of capabilities is stored in the mServer capabilities list. Use a for loop and a print function to display the device capabilities. Okay, add these 3 lines at the end. Go to virtual machine, go to the file, the text file, and down here, copy these 3 lines from prim to print capability and add at the end. Enter. paste. Okay, be careful with alignment, tabulation, and indentation. Okay, print this. This is only a title, only a title. Don't worry about this. But for capability variable in m variable, server capabilities. This is the list, and you will print all the capabilities. Okay, save and run. The output is same output you got from sending the complex hello message, but without the opening and closing capability XML tag on each line. Okay, okay, file, save, run, run module. Okay, you got all capabilities. Compare with the previous. Look at this. You got the capabilities, but you have the capability tag, the XML format, capability. But here you don't have those tags, as you can see. Use ncclient to retrieve the configuration. You will use the netconf-yang to retrieve the configuration of R1. Update the configuration and create a new interface. You will also learn why the transactional support of netconf is important for getting consistent network changes. Use getConfig function to retrieve the running configuration for R1. You can use getConfig method of the mnetconf session object to retrieve the configuration for the router. The getConfig method expects a source string parameter that specifies the source netconf data store. Use a print function to display the results. The only netconf data store currently on R1 is the running data store. You can verify this with show netconf-yang data stores command. If you want to skip displaying the output from part 3, comment out the block of statements that print the capabilities as shown in the following. Okay, command this to not print the capabilities and add this at the end. Okay, on the virtual machine, the text editor, copy these 2 lines. The netconf replay and print netconf replay, only 2 lines, copy, enter, add at the end. Okay, netconf replay, print netconf. Comment this, comment the block with 3, 1, 2, 3. Okay, comment it. Okay, comment this to not print the capabilities, and netconf replay get config. The source is their data store, so you can verify. You can verify this with the show netconf-yang data stores command. Okay, on the virtual machine, on this window, enter, 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 Control C, Control C. Okay, it's not working. Close this, close terminal, open a new terminal. Up arrow, SSH, developer sandbox, ISXC, latest one, cisco.com, enter. C1 SCO 1 2 3 4 5 enter. And use show netconf-yang data stores. Sorry, data enter. Okay, the data store available is running based on the running configuration. Okay, save and run your program. The output will be over 100 lines, so ideally you may compress them. Double click the explicit text message in the ideally shell window to expand the output. Okay, review the module, the connection. This is commanded netconf replay, get the config, the source is the running, and print the response. Save, run. Explicit text 204 lines. Double click here and you will see all this information. This is the configuration of the device. Okay, and you can see, for example, the host name here. Host name, the enable secret password, encrypted. Okay, and more configurations like interfaces. Notice that the return XML is not format. You can copy it out to the same site you found in part 2 to prettify the XML. Okay, and copy all this information. Copy. Go to Firefox, up here. Okay, remove this, paste, and turn pretty. And the result the processor, hostname, enable password, the username, developer, and password, another user, domain, routes, gigabit interface 1, gigabit interface 1, gigabit 2, gigabit 3, and so on. Use Python to prettify the XML. Python has built-in support for working with XML files. The XML DOM mini-DOM module can be used to prettify the output with the toPrettyXML function. At the beginning of your script, add a statement to import the XML DOM mini-DOM module. Then replace the simple print function. Print netconf replay with a version that prints prettified XML output. Import XML DOM mini-DOM and print Okay, go to virtual machine, the text editor. Okay, here import XML DOM, mini DOM, and print 2 lines. At the end, enter and paste. You can cut this and place it up here. Okay, now review ncclient module, mini DOM module, the connection, and then replace the simple print function print netconf replay with a version that prints predefined XML output. Okay, so remove this and use the print DOM mini DOM. The netconf replay variable, this in XML format and to pretty XML to prettify. Save and run. Save and run. (690) lines, double click and you will see a pretty XML. The host name, enable secret, the same information but more readable. Okay. Use a filter with getConfig to only retrieve a specific Yang model. A network administrator may only want to retrieve a portion of the running configuration on a device. netconf supports returning only data that is defined in a filter parameter of the getConf function. Create a variable called netconf-filter that only retrieves data defined by the Cisco IOS XE native Yang model. Okay, this is the filter, and the replay will use the filter. The source is the running, but will apply the filter to get only data defined by the Cisco IOS XE native Yang model. Okay, and copy this. Virtual machine, text editor. Okay, netconf filter, netconf replay, these lines, copy. At the end, enter, paste. The source is running, print the XML output, create the filter, the reply, the source is running, but apply the filter, this filter, but add this at the end, copy, enter and paste. So you can print the result, the netconf replay output, pretty XML. Okay, and save and run your program. Expand the output to see XML displayed in a more readable format. The start of the output is the same. However, the rest of the output only includes specified Yang models. Okay, file, save, and run. Okay, squeeze text 690 lines. Double click here. Okay, this is the output for this part. Okay, that is very good. But at the end, there is an issue, an error for this. It's not applying the filter. Okay, there is a problem with the filter. And that's why is the sandbox device I'm using is version 17.31, the latest code. Use a previous version. Okay, go to sandbox, get started with sandbox. Always on, use this iOS XE on CSR recommended code 1693, a previous version. Okay, click here. Okay, this is the device. iOS XE CSR recommended code 1693. But the credentials are different. Sandbox iOS XE recom 1 port, SSH port, netconf port, restconf port, username developer, password C1ICO12345. Okay, so use this. You need to change here on the connection. Host sandbox iOS XE recom double M-1 Cisco.com. Netconf port is the same, username is the same, password is the same. Very good. These two lines to show the configuration of the router. This is the filter. Then the source will be running. Apply the filter. Okay, get config method and print the result. File, save, and run. Okay, squeeze 660 lines. Double click. Okay. Very good. Okay, this output is for these lines. With this another output, exquisite text 305 lines is for this. Okay, double click. Okay, you can see. The management interface. Hostname, enable secret. Gigabit 1 and more information. Filtering the retrieved data to only display the native Yang module significantly reduces your output. This is because the native Yang module only includes a subset of all the Cisco iOS XE Yang models. Use ncclient to configure a device. Use ncclient to configure R1 using edit-config method of the manager module. Use ncclient to edit the hostname for R1. It is fine if multiple students are accessing R1 at the same time and changing the hostname. You will be looking for the OK response from netconf, which confirms your configuration was sent and applied successfully. The current hostname is unimportant. To update an existing setting in the configuration for R1, you can extract the settings location from the configuration retrieved in part 4. You will set a variable to change the hostname value. The tags for hostname. Previously, you defined a filter variable. To modify a device configuration, you will define a config variable. Add the following variable to your ncclient netconf script. You can use new hostname or whatever hostname you wish. Okay, this is the filter. Okay, on the virtual machine, text editor. Here, copy this netconf hostname variable. This is the filter. Copy. At the end, paste netconf hostname. Config native. This is the hostname. Use edit config function to the mnetconf session object to send the configuration and store the results in the netconf replay variable so that they can be printed. The parameters for the edit config function are as follows. The target netconf data store to be updated. Okay, the target will be running. Config the configuration modification that is to be sent. The config is netconf hostname, is the filter, is this variable. Okay, and the method is edit config. So copy this on virtual machine, text editor, this netconf replay, edit config, target running, config netconf hostname, copy, enter, paste here. Very nice. This the edit config function returns an XML RPC replay message with OK indicating that the change was successfully applied. Repeat the previous print statement to display the results. Okay, this is the print XML DOM mini DOM to predefine the XML output. The virtual machine, text editor, this print XML DOM mini DOM. Okay, this line. Okay, at the end, enter, paste, enter. Save and run your program. You can also verify that the hostname for R1 has changed by accessing the router command line interface. And here on the filter, you can use, for example, CSR 1k 1 kb 1 kb, for example. To note the change, apply the filter, edit config, target running, apply the configuration, apply the filter, and print the output. Okay, save, run. Okay, and you will see OK. OK means the change was made. Verify on the router, enter, Control C. Okay, close this, close terminal, right click, new terminal, and up arrow, SSH connection, username developer, hostname is different. Remember, my hostname is recom-1. Let's modify this. Recom-1. Enter. Yes. Password C1SCO12345. Enter. And now you can see the new hostname, CSR1KB. CSR1KB. Very good. Change the hostname of the router back to R1. Or okay, you can change the hostname using Python or using command line interface. Okay, I will use command line interface configure terminal hostname CSR 1000B. Okay, enter, and okay, the hostname. Use ncclient to create a new loopback interface on R1. Comment out the code from the previous step if you want to avoid changing the hostname again. Okay, you can comment this block. Okay, comment this to not change the hostname again. Create a new config variable to hold the configuration for a new loopback interface. Add the following to your ncclient netconf script. If multiple students are accessing the router at the same time, use the loopback assigned to you by your instructor. Otherwise, you can use loopback1. Okay, replace student name with your name. Leave the backlash in the description command. The escape character backlash allows an alternative interpretation of the single quote as the apostrophe. The escape characters allow special characters to be used inside a string declaration. The single quote is normally used to know the beginning or the end of a string declaration. Okay, netconf loopback, native, loopback number, description. You can use the name, your name, IP address, and subnet mask. The virtual machine, the text editor. Okay, this netconf loopback, copy at the end, enter, and paste. enter. Very nice. Okay, comment out the previous netconf replay variable if you want to avoid changing the hostname again. Okay, comment out this. Okay, now is commanded to not change the hostname again. Add the following edit config function to your ncclient netconf to send the new loopback configuration to the router and then print out the results. Okay, the target running, edit config, netconf loopback to apply the configuration and print virtual machine, this text editor, these two lines, copy and paste, enter. Netconf replay, edit config, target is running, the config is netconf loopback, this variable, and print the results. Save and run. You should get OK. Save, run. Because you need to change the description. Maybe use your name here and a different number of loopback, like 3333, and a different IP address, because if this IP exists, the loopback will not be created. So use a different number like this. And use another subnet mask. For example, okay, be careful, the loopback, change loopback interface, description, different IP, IP that is not existing in the configuration, and a new and use this mask or another mask. Okay, save and run. Okay, OK. And verify the loopback was created. Show IP interface brief. Okay, on virtual machine, this enter. Okay, SSH timeout, close terminal. Right click, new terminal. Up arrow and repeat SSH developer sandbox ISXE recom1. Remember recom1, enter. Password C1SCO12345, enter. Show IP interface brief, enter. Now you can see loopback 3333, this IP, very nice. Attempt to create a new loopback interface with the same IPv4 address. Create a new variable called netconf new loop. It will hold a configuration that creates a new loopback2 interface, but with the same IPv4 address as previous loopback. At the router command line interface, it would create an error because of the attempt to assign a duplicate IP address to an interface. If multiple students are accessing the router at the same time, increment by 1 the loopback assigned to you by your instructor, otherwise you can use loopback 2. Okay, apply this. Okay, copy and paste this to the code. Virtual machine, text editor, netconf new loop, copy. At the end, enter and paste. Okay, the previous was netconf loopback, now is netconf new loop. Add the following edit config function. Okay, use this line. Okay, use this line. Netconf replay, edit config, target running, netconf new loop. At the end, enter, paste, enter. Okay, the target is running data store. The configuration is netconf new loop. Netconf new loop. Okay, finally print. So copy this to print the pretty XML. Enter, paste, enter. Okay, this netconf replay, this, and remove all this. Okay, remove all this. The previous code to create the first loopback or comment. Remove or comment. Okay, I will comment. Okay, comment this to not create the previous loopback. And here on netconf new loop, create another loopback, for example, 4444, but use the description. Use this description. Okay, use this description or choose another description, any that you want. But the important thing is to use the same IP address. You will try to create a new loopback with the same IP address. Copy the IP and paste. And the same subnet mask. Okay, this is commanded. The number was 3333 already created. The new loopback, netconf new loop, should be a different loopback number. I will use 4444, but use the same IP address as the previous loopback, the same IP address. The description can be any. Okay, apply the target running, netconf new loop is this, and print. Save and run. You should get error. Okay, let's see what happens. Save, run. Error. Very nice. Unlike using netmico or copying and pasting a script, netconf will not apply any of the configuration that is sent if one or more commands are rejected. To verify this, enter the show IP interface brief command on the router. Notice that your new interface was not created. Okay, review. Okay, go to this window, enter, Control C, close this, close terminal, right click, new terminal. Up arrow, SSH developer sandbox ISXC recom1, enter. Password C1SCO12345, enter. Show IP interface brief. Okay, loopback 333444 was not created. Very nice, because this error duplicate IP address. Modify the program, use it in this lab. The following is the complete program that was created in this lab. Practice your Python skills by modifying the program to send different verification and configuration commands. Okay, you can create a new loopback. For example, 4444, but use a different IP address with this subnet mask or another. Save, run. Okay, and on this window, enter show IP interface brief. You will see your loopback address, and you can remove these loopback addresses on command line interface. Configure terminal, no loopback 3333, no interface loopback 3333, and no interface loopback 4444, and show IP interface brief. Now, very good. Thank you very much.